order to give name to aromatic compound, we can name it according to Commons name or IUPAC name. For the IUPAC's name, the monosubstituent benzene can be named as a hydrocarbon with benzene that attached to substituent. For example, we have C6H5Br. So this is benzene that attached to Br. For C6H5NO2, it is called nitrobenzene, whereby benzene attached to nitro group. And for polypropylbenzene, we have here benzene that attached to propyl groups, which is 3 carbon. For the common name, for example, here we have methylbenzene. Okay, so this is methylbenzene, whereby benzene that attached to CH3. So it can also known as toluene. Another example, we have aminobenzene, which also known as aniline. So how the structure of aminobenzene is supposed to be benzene that attached to NH2. So for phenol, how the structure of phenol? We know that phenol is a benzene that attached to OH group. So it is called phenol. Here's some of the names for monosubstituents. Okay, for example, we know that NO2 is nitro, Br is bromo when it is substituent, Cl, which is chloride, when it becomes substituent, it will be chloro. For CH3, when it becomes substituent, it is methyl, followed by ethyl, which is 2 carbon, and propyl, which is 3 carbon. For two substituents, it can be named with respect to relative position on benzene ring. For the first structure, there are two substituents located at carbon 1 and carbon 2. So it is 1,2 disubstituted. The parents now is benzene. So in order to name this structure, we need to put ortho here, meaning that the substituent located at carbon 1 and carbon 2. So its name is ortho because it has 2 chloro. So you have to put dichlorobenzene. For the second example, we have two substituents here which located at carbon 1 and carbon 3. So this structure is actually a common name that we know as a xylene. So because the substituent located at carbon 1 and carbon 3, so we need to put meta. So the name for this structure is metaxylene. For the third structure, we have two substituents here located at carbon 1 and carbon 4. So we need to select the parents. For example, in this case, the parents, we can put a name for common name, which is benzaldehyde. Okay, so to start numbering, you have to consider to put number 1 at the parents. Okay, so here will be number 1, 2, 3, 4. So the next substituent is located at carbon number 4. So because it is 1,4 substituent, so it is called para chlorobenzaldehyde. For aromatic compound that have more than two substituents, choose numbers to get lowest possible values and list substituents alphabetically with hyphen numbers. For example, structure number 1, the parents now is a benzene and it has 3 substituents. To name the structure, we need to start numbering to get the lowest possible value. So in this case, I put number 1 at this CH3 and I go anti-clockwise. So we have here 1, 2 dimethyl and 4 bromo. You can try to put number 1 at BR and follow clockwise, okay, following clockwise. So you can have 1 bromo, 3, 4 dimethyl, which will give you higher values compared to 4 bromo, 1, 2 dimethylbenzene. The third example here, the parents here is toluene, whereby a benzene that attached to CH3. So we can put a toluene as a common name. So at toluene, there are three substituents that located at carbon number 2, 4, and 6. So we can name as 2,4,6 trinitro-toluene. What happens when alkyl is a longer chain compared to benzene? When alkyl has more than 6 carbon, so alkyl now will be as a parent and benzene now will be as a substituent, which can be called as a phenyl group. This is a phenyl group whereby benzene now as a substituent. In this example, we have the parents here which have 7 carbon, which known as a heptane. So now benzene become as a substituent. So the normal practice, we want to get the smallest possible number of substituent. So you must start to give number from left, which is 1, 2, and now substituent located at carbon number 2. So the name will be 2-phenylheptane. You will not start to number from right, whereby if you start number 1 here, so you will get 6-phenylheptane, which is wrong. For the benzyl group, this is benzyl group which known as C6H5CH2. So we know here benzene that attached to CH2. Let's go through these two examples. Examples number 1, we have parents here is phenol and BRS substituents. So you must start to give numbering considering the carbon that attached to OH, okay, because this part is parents. So you give number 1 here is either clockwise or anti-clockwise. It doesn't matter as long you get the smallest possible number here. So in this case, we have 2,6-dibromophenol. Second example, this part will be as a parent, which known as a benzoic acid. And um, this carbon we should put as a number 1 and Cl located at carbon number 3. So we can write as a meta-chlorobenzoic acid, or you just can write M-chlorobenzoic acid. In benzene structure, all its C-C bond are the same length. The electron density in all 6 C-C bond is identical. Benzene can be said as a conjugated system whereby electron in this 6 carbon can move from one carbon to another. It has planar and a hexagonal shape, and the C-C-C bond angle is 120 degree. Each carbon is sp2 and has a p orbital perpendicular to the plane of the 6-member ring. So imagine benzene is a planar. Okay, so there will be a p orbital that coming out from the plane. So each carbon has p orbital. If I can draw here, so you have to imagine in terms of 2D structure. Okay, so it is sp2 hybridized at each of the carbon. Benzene can have 2 resonance structure. Okay, here the first structure, as the electron in the benzene ring can be delocalized, meaning that electron can move inside the ring. Okay, so we can have another structure of benzene, and these two structures can be said as a resonance. We can also draw the benzene structure by putting a circle inside the benzene ring. So it is understood benzene that have delocalization of electron. So benzene prefer to undergo substitution rather than electrophilic addition.